Hi there, this is Ian McTavish from Team 4152, and this is tutorial 8 of our TechnoGirls MiniBot series of tutorials, and we're working on our wheels and shaft now. Again, we always need to thank our sponsors with which this allows this to happen. So we're designing a mini robot, and today we're going to work on wheels and shafts. And basically, we have these wheels. They're 4-inch in diameter, and you'll notice that they have a hexagon for where the shaft goes. And that's what we can use, but our goal is we're going to design wheels and make them out of plywood, just so that we can develop some other skills that I want to focus on. So in onShape, it's really important if you click on different parts, you can get distances between them. So I angled my view so that I could click on the inside of the square tubing and the inside of that, and I can see that the distance between them is 2 inches. And the key thing is that it's actually going to be a little bit less because I need to keep in mind the bushings. So when we have a shaft that spins, we need it to be able to spin smoothly. So you have a couple of options. The option that we like to use the most are bearings, and this is an example of a bearing. And you have little ball bearings inside of it and they spin. So this works really, really well. The problem is our 1-inch square tubing is just a little bit too small. So this year we were doing an intake that was going to be out of 1-inch square tubing because the size we needed. So we tried using these types of bushings and they worked really well. There's a little bit more friction than a bearing because it's a solid brass, and whereas the bearing has the wheels that allow it to spin. But it seemed to work really well, so we're going to try using that for our little mini robot. Fastenal is a company that we like to get a lot of these supplies from, and so it's really important to go there, and I made note of what the part number is. But what's important is this flange, we need to make sure that we figure out the thickness. So the thickness of that is 0.063 inches. And that's going to stick out of the square tubing. So when we're making our shaft, we need to keep that in mind. Now we tend to use Hex Shaft for shafts. The reason is that if you use a round shaft, you got to figure out how to secure that wheel. And with the Hex Shaft, it works really well because the wheel slides onto it, and the hexagon shape means that when the shaft turns, the wheel will turn as well. So that's why we tend to use Hex Shaft as much as possible. So we're ready to get started. So I'm going to switch over to onShape now, and we're going to get going. So the first thing is that we're going to create a new part studio. So we're going to click the plus sign, and we're going to click Create Part Studio. And we're going to rename it. So I'm going to rename this Part Studio Axle. So you notice in the Tab Manager, I'm right-clicking and renaming. And if you don't see the Tab Manager, down at the bottom is the little magnifying glass. And that is how you can open up the Tab Manager. So this is going to be the axle that I'm going to be working on. And so I'm going to do that. And I'm going to select a plane. I don't want the top plane because then I have to turn my wheel up. So I'm going to use the right, because if I set everything up correctly, then it would be there. So clicking the right plane and then clicking sketch will bring me into the sketch. And just a reminder from an earlier tutorial, when you have this little sketch box up, you can see the toolbar. So if you're missing that, then you're not in the sketch. Clicking the green will save your sketch. Clicking the red is not good because it will delete it. It will delete anything you've done since you started that particular time. So I'm going to press N on my keyboard. That normalizes my view so that I can easily see everything. And in onShape, we've been doing rectangles and circles, but there's other tools. So we're going to use the polygon tool. So the polygon tool is pretty neat. I can click on the center, and you can see I'm holding my mouse over the origin. It goes orange, and the little coincident icon pops up showing that when I click, this will lock the center in place to that. And I can move my mouse, so I'm going to click a second time. Now, this second time, after I click, the little number 6 comes up. So if I move my mouse, this will change how many sides my shape has. So I want to make sure that I get it so that it's on 6 and then click a third time. So take your time with these things. It's really easy to make a mistake, so just go slow. If you run into problems, undo and try it again. So I'm going to click the pentagon or the polygon tool to turn it off, and I should have a 6-sided hexagon in on my screen. Now, there are constraints over here, and again, depending on your screen resolution, you might not see all of them in a line. You might see one of them with a little drop down. So you want to look for these two icons. If you don't see all of them, look for search tools, and then right beside it on the left with the drop down should be it. So the horizontal tool, I'm going to click that, and when I hold my mouse over it, you can see these pop-ups are really helpful. So I can see I don't need to click the toolbar. I can type the letter H to get this tool. So I'm going to just click the horizontal, and I'm going to click this line. You can see it's highlighted in orange. It's the top of my polygon, and that will force my line to be horizontal. It looked horizontal, but it wasn't quite, and now it's just positioned it slightly, so it's perfectly horizontal. Now, I'm going to use the dimension tool. So the dimension tool is a really powerful tool, and there's directions when you pop your mouse over it, so I always encourage you to read those directions. So I'm going to click the dimension tool, and when I click it, now the order that I click things will allow me to set dimensions. So I'm going to click this line to begin with, and then I'm going to move my mouse down and click on the bottom line of the hexagon and move my mouse to the side. And what this allows me to do is set the distance between those two lines. So I'm going to click a third time, and now I can type in, and I'm going to type 0.5 IN for inches. So that will resize my polygon, and you'll notice my polygon is completely black now. That means it's fully constrained. It knows exactly where it's positioned. It knows that these lines are horizontal and that this is 0.5 inches away from the other line. The next thing that I'm going to do is I'm going to use my circle tool, and I'm going to click in the center, and again I'm looking for the orange to make sure that everything is locked in place. So I'm going to click once, I'm going to move my mouse, I'm going to click a second time, and I'm going to type 3/8. And 3/8, 3/8, is the equivalent of 0, and notice I'm turning off my circle tool, 0.375 inches. So I have a 3/8 inch shaft, and I've got a 1/2 inch hexagon. So I'm just going to save my sketch. You'll notice that I'm naming it. Get in the practice of always naming your sketches so that it's easy to find them. So there we go, I've named it, and now I am going to click the extrude keys. So with the extrude, I'm going to select the circle to begin with. And what I'm going to do is I'm going to, first off, going to give it a name. So this is going to be the round part of the axle. And I'm selected the round circle. And I am changing this blind. If I'm just going to move this, you can see that from the plane, blind means you're going in one direction. What I want is symmetrical. So symmetrical will mean my sketch is in the middle, and if this is 1 inch, then 1/2 inch is that direction and 1/2 inch is that direction. So I'm going to type in 2.5 inches. 2 inches is the distance between my square tubing, and so my shaft will go 1/4 of an inch in to the bushing on one side, 1/4 inch on the other. So that's the dimensions. So it's really important to make that to select it. And the reason it's important is because it means we can use a few less steps for the next part. So right here you can see my axle is my sketch is hidden, so I'm going to click the eye so that I can see it, because I need this for stage 2. So stage 2, I'm going to click extrude once again. This time I'm going to click the hexagon shape. And in the hexagon shape, it's adding, so that's perfect. And instead of blind, I want it symmetrical. Now, the depth is a little tricky. So 2 inches was the distance. So I'm going to do 2 subtract 0.063. If you remember, that was the thickness of the flange times 2, because I'm going to have a flange on either side. So I can type in math and it will automatically calculate that distance. And I've got all the parts. I'm going to name it so that I know what part that particular extrusion is. So I now have a part that is hexagon and round at the end. Whenever you're designing parts, you always think, how are we going to make this? And that's what we are actually going to make these on the lathe. And basically we'll start with Hex Shaft and we'll run it on the lathe and we'll carve out so that we've got the round part on either end. So I'm going to name my part, and basically I'm going to go into properties, and my part is axle, and my part number, TG is the initials for TechnoGirls. So with our robot, we always use our team number, 4152. The next 2 initials are the name of that particular robot. So MB for MiniBot. In competition season, it's always the year that we use for competition season. And then this is a part, and it's part of the drivetrain, so 01, and I believe it's 04. 1, 2, 3. Yep, so that's my part. And I can also assign a material, and it's aluminum. And I'll need to double check. I believe it's aluminum 6061, but I'm not too concerned. It's mainly so that it generates the mass for it, but I need to check what it actually is. So that's the axle. That's great. And now we're going to design our wheel. And so for the wheel, our wheel's going to be it's going to have a hex shape in the middle, and it's going to be 3 inches. And the reason for that is the hex shape allows us to slide on, so that's great. So we're going to use the CNC to cut it. And this is where we run into a bit of a problem. And I'm going to just quickly jump through. So here's the problem. If we're cutting the inside of a shape on our CNC router, so this round part, if you think of this is a bit. So it's spinning really fast and it's carving as it goes. So going around the outside, no problem at all. You're able to get nice, perfect 90-degree corners. When you're doing the inside, you run into a problem because it will go up and then it goes across, and you're left with that little piece of red in there will be filled in. And that's where the issue is, because now we try to put our piece through here and it's going to snag on that particular part. So that's the issue. So there's a bunch of different solutions, and for this type of thing we're going to use the Dogbone solution. And the Dogbone solution is basically we're going to add a circle in each corner, and the circle's the same size as the bit. So as the bit comes in, it can fit into the circle and fit out, and that way we can get the same shape. And our piece can fit on nicely because there's no material stuck in the corner preventing it from getting in, and it's easy to manufacture. So we always need to think about, how are we going to build something, how are we going to manufacturing it. So I'm going to be showing you how to do that. First things first, we need to create a new part. So I'm going to create a new part studio. Typically I would actually make it in the same part studio. And the reason I'm not doing it in the same is because I find when you're learning this, it gets a little complicated when all the different sketches and stuff. So I like to separate them when I'm learning, and then as I'm building stuff, anything that kind of fits together, I build in the same part studio. So again, I'm going to use the right, and I'm going to click Sketch, and I'm going to press N, which allows me to normalize my sketch. And my polygon, very similar to what I just did. So polygon, I'm going to click, going to move, I'm going to click again, click a third time to set the 6 sides. Always turn off your tool so you're not randomly making polygons. Set a horizontal constraint. There we go. And now I'm going to set my dimensions. Now, the difference is my dimensions are going to be slightly bigger. And the reason is, so I've clicked the dimension tool, click that line. So if I typed 0.5 inches, the problem is that when a hole and an object are the exact same size, the amount of friction, it's incredibly hard to get them on. So I'm going to make the hole just slightly bigger. So 0.51 inches seems to work really well. So whenever I'm building something like this, I always add 0.01 inches to make it just big enough that things will slide on. Now you notice when I do holes for screws, I don't do that because we've already figured out the size that works well, so there's no reason to add to it when we've already got the size. Now, there's a bunch of strategies that make this easy. I'm going to use the line tool and the construction tool, and I'm going to click on this corner and move my mouse to the following corner. So, and just hit escape because we don't need to set the height or the length. So again, line tool, construction tool, starting with this corner and clicking on that one. Now, if you get all red, that's okay, just undo it. It's something to do with the geometry of this, so I just use the opposite one, and then it seems to work. So when you run into the red, always try to figure out undo and fix it. And with this, all I care about is the diagonal, so I just start at the other point, and that seems to solve that problem. I don't need to worry about this line because I've already got the axes that I can use as a reference point. So the reason I'm doing these diagonals is I am going to use them to lock my circle in. So here's my circle, so I'm going to hold my circle over the line. So this will force my circle to have the center stuck on that line, and I'm moving my circle. Do you see how that corner point is now highlighted in orange? So that is my circle, and I can set the height of that. 1/8. I'm going to use a 1/8 inch bit to carve this particular part out. So that's how I can do it. So there's my circle. I need to do that for every corner, and this is where I'm doing it fairly fast. You're going to take a little bit longer if it's your first time doing this. Don't just take your time. And you'll notice with this one, I'm just making sure as long as that's orange, then it lines my my constraint is in there. So I'm just going around and clicking. And if you ever run into a situation where something got red, then just undo it, and you'll be able to fix it. Again, take your time. Okay, so there's my circles. So I've got a circle in every corner, and what I need to do now is I'm going to trim these circles. So I'm just going to zoom in so I can see what I'm doing. And you can see there's a little scissors tool. This is your trim tool. So with the trim tool, if I hold my mouse there, you can see it highlights that little segment. So it breaks up the line based on this. Now, I'm just going to move this dimension over here because it looked like there was another line, and there really isn't. That dimension line is there. So what I'm doing is I'm clicking that, and I'm clicking the parts of the circle that are inside, because what I want to do is I just want this curve right there. So I have set up this curve, and I'm doing the same thing here. And again, take your time, just one step at a time. You'll see that this is shaded. I'm just going to make a mistake, and all of a sudden it's no longer shaded because I accidentally deleted that line. So if you work slowly and undo when you make a mistake, you can get through this Whoops, I've got to select my trim tool again. And there we go. Just going to quickly get these done. So this will allow me to have the circle, and I don't need to click a whole bunch of stuff. I've made that mistake before where I haven't bothered to do this, and I had to click stuff, and then it was really frustrating because I missed a tiny little piece in there, and so things weren't working, and it was just very frustrating. So I like to get this stuff done at this stage so I don't need to worry about it. And there we go. Not quite. So I have clicked this, so now I've got my hexagon with its little dog bone corners, and so that is excellent. And if I'm just zoom out a bit, you can see there is the hexagon. That's what it should look like. And I'm going to save that. Or no, I'm not done. Sorry. Now I'm going to add a circle. So my circle is going to be centered. So I hold it so it's orange. Perfect. I'm just going to click out here and I'm going to type 3. Zoom out. So the diameter of my circle. Whoops. I'm just randomly clicking stuff I want. There's my 3. I just like to move it over so it's easier to see. So this gets a little bit busy in here. That's okay. So there's my circle. Everything's the way I want it. So this is my sketch wheel. I can save that. Now I can extrude my wheel. And we're going to use 3/4 inch plywood, which is 0.75 inches. And we'll just click the wheel. You could also select the sketch and it would pick it, and extrude wheel. And there we go. There's my wheel, all nice and go. I'm going to right click the part and my properties. The name for this is wheel. My part number is TechnoGirls MiniBot part 01, so it's part of the drivetrain assembly. -05, it's the 5th item that I've made in the drivetrain assembly. And save. And if you forget your part numbers, don't stress. There's a later tutorial we go over how to see all of them at once so that you can fix any mistakes. And assign material. I'm going to click, and we're going to use birch plywood, Baltic birch plywood, to make it. And that is our wheel. We would have added tread to it when we manufacture. I'm not going to add that to the drawing because it's just a little extra step that I really don't need. I've got my axle. Hope this was helpful, and thank you for checking our tutorials. If you find them useful, can you please email ian.mctavish@tldsb.on.ca to let us know. We try to track that information for our chairman's submissions for First Robotics competition. Have a great day.